Welcome to physics on Tuesday, September 22nd. Today, our goal is to complete a pre assessment. And so, just a reminder about pre assessments, they're not going to be added to the grade book, and you're not expected to know everything. The goal might be that you know something and that you might be able to apply what you know to this situation. But really, by the end of the semester, the goal is that you're going to be able to do really well on this this assessment, this pre-assessment. So again, right now there's no pressure, but it really helps me as the teacher understand where you're at, and it really helps me know what needs to be done to get you kind of to the place where you can do well on this test. So, while it might be overwhelming, or you might go, I don't even have a clue how to start this, that is totally okay. And again, the goal is that eventually you will. And so it'll really be able to show you kind of what you've learned this year. And so just keep that in mind. Okay, do your best. I don't want you spending hours and hours on it. I don't want you looking up answers because that doesn't help anybody. Um, so just kind of do your best based on what you already know. Okay, so again, this is in the calendar. I'm kind of making it right now, but you're going to go to the Physics One pre-assessment, and it'll open this site for you. Okay, and the directions: answer the following questions to the best of your ability. If you try something, make sure you show your work, and I'll kind of demonstrate that here in a minute. Or explain your reasoning in the boxes provided. The reason for this is let's say you try something, uh, and it's totally kind of off from what the final answer should be, but you start explaining yourself and we go, okay, they're not actually, that far off. Or let's say you get the answer wrong, but you don't, or sorry, let's say you get the answer right, but you don't know how to explain it. That also kind of tells me, was like, well, maybe we need to deepen their understanding here. So, showing your work can really help me learn a lot about what you know. And if you're not sure about how to approach the problem, that's okay. I really want you to try something, okay? So, looking through this, problem one, it's a little scenario here. So, Mr. Martin rides his bike from downtown Hillsborough to a low high school, taking a safe route that measures 13.5 kilometers, and it takes him exactly 30 minutes. So, I want to know, can you determine my average velocity in kilometers per hour? Okay, so you would type your answer here, and then you can click this for show your work. And you see that you have all these options over here. So if I wanted, I could go, okay, well, you have 13.5, and you can kind of draw it out. On your Chromebooks, it might be easier with your finger, or if you have a stylus, it might help. You also have shapes that you can add. Okay, well, he's going, this far in this amount of time. You can kind of draw yourself a picture if you want with those different shapes. You can also change colors and thickness of your lines. Okay. You can erase. Let's say, okay, I don't know what I was doing there. So you can erase that. You can add text. So if you're trying to explain your reasoning, you can type it in here. Okay. And again, your answer can go here. And if you click the check mark, I'm going to see your your work, and I'm going to see your answer. Okay. Then, what is his average velocity in meters per second? So I'm asking you to convert from kilometers per hour to meters per second. Okay. Then, which of the following graphs shows the motion of an object with a constant velocity? Again, I don't want you to look anything up. If you have an educated guess, if you don't, you might select one and tell me, I kind of just guessed. Um, and then select all that apply. There might be more than one correct answer, so you can check multiple if you desire. Okay. And there's 4 possible graphs. Okay, problem 3. This is just a multiple choice. Select one. Okay. Relationship between distance and time for an object with a constant acceleration. Linear, quadratic, logarithmic, and no relationship. So you could select one of those. And then I really want you to at least explain your selection. So at least explain your selection. Okay. Again, every single problem, I really kind of want you to show your work here. Problem 4 is a little different because there's nothing for you to really select, but what I've done is I've embedded this table for you, and then I've required that you show your work. So for each of the different properties of motion, we have distance, velocity, and acceleration, our properties of motion. List as many units of measurement. We've done a little activity on measurement that might help us with at least one of these columns, hint, hint. And then I come in and show your work. So you can really kind of draw all around this if you really want. But the idea is, one, you can zoom in, and then you can put a little text box. Okay. And, feet, miles. Okay. So those are distances that we haven't talked about, but that we're kind of familiar with distance. And so you could type in your answers here. Okay. And actually, just to show you, I'll put miles in there and feet. And when I show you, I click my answer. You can see that I will see everything that you put in to this data table. Or informational table. Okay. Next, problem 5. This is kind of the grand finale, really. So, pro skater Leo Baker launches off a vert ramp and stays airborne for 1.5 seconds before landing back on the ramp. By the end of this semester, we're going to learn how to take that information and determine how high above the ramp in meters did they reach on the jump. You would type it in here, show your work. Maybe you draw a little model of him going up and down. What was their initial velocity at launch? You're going to be able to determine that if you can't already. And what is their final velocity at landing? So again, not a lot of information there, but it's loading. But with this information, we're going to be able to determine that. So pretty cool. Give me your best educated guesses, if need be, if you don't know. But that's going to be it. And that's for Tuesday and Wednesday. Okay. So I don't want you to feel like you have to sit and struggle over it for a long period of time. But I am giving you Wednesday as well to work on this. And then what this will allow us to do is start really our first unit of motion. And we're going to start talking about these properties of motion on Thursday is the goal. Okay. Let me know if you have questions. Email me, message me in Canvas. But good luck.